Good morning, ladies and gentlemen. We're going to go ahead and do a little review here, and we're going to start with this question. Miss Moore holds a bowling ball. How can she do positive work, negative work, and how can she do zero work?
Well, what's the direction of the force that Ms. Moore is exerting on the ball right now?
Well, my force is up, right? Because it's not falling.
Yep.
Right. So for positive work, the force and the displacement have to be in the same direction. So if force is up, displacement has to be up. Positive work.
Positive work.
Okay. So how can I do negative work? Well, which direction is my force in the ball still?
It's got to be up.
It's got to be up. And so if I want to do negative work, the force and displacement have to be in the opposite direction. So the force is up, displacement has to be
Down. That's
down.
negative
work. Oh, my arms are burning.
work.
And how can I do no work?
Well, you could just sit there and
Okay.
not do any displacement.
Uh-huh.
Or
what was that one perpendicular to the force?
you could just walk horizontally.
Yeah. So I'm not doing any work. Hard to believe, I know. No work is being
Your
done
arms are
here.
getting tired.
Yes, they are getting tired. I'm gonna put the ball down. Ooh. Alright. Parts of a right triangle. This
Okay.
should look really familiar.
Now, what we're doing here is we're going to take a half test here, half quiz,
Mm-hmm.
and we're just reviewing stuff that they already know to get them ready for the quiz.
Yes. Good. I'm glad you added that. This is easy. The hypotenuse is the long side.
Yep.
Triangle parts are important. The adjacent side is the side that's touching the angle. That's not that long side.
Notice the color coordination with blue
Oh.
for adjacent side and the blue for the line.
Very well done.
Oh.
Okay. And what about the opposite side? Is opposite of the angle.
Yep.
Oh, okay. Identify the parts.
A must be the,
The angle's here, so A is going to be the opposite.
yep,
B is going to be the adjacent, and C is going to be the hypotenuse.
it's
That's
the
long
longest
side.
one. That's simple stuff.
Easy, okay. Oops. Vector resolution. So vector resolution, any vector can be resolved into two perpendicular components. That's when you have the hypotenuse, and you got to figure out what is this part and what is this part.
That's right. This is review.
The compass.
The components.
The components can be north-south and east and west, or horizontal and vertical. So sometimes when I'm asking you to resolve vectors, I'm asking you to tell me what the north and the east components are, or I might say the vertical and the horizontal components.
It depends on what the situation is.
Yeah. And all that you need to know is which way is north, south, east, and west, and which one is horizontal and vertical.
Yep.
Okay, solve for the opposite here, and then solve for the adjacent here. I'll do it over here.
That's just A is equal to B over C. That's easy.
So if I want to get opposite by itself,
That's division. You undo it with multiplication.
these cancel.
You guys have done this.
You guys have done this. You guys have seen me do this a million times. You're like, Miss Moore, we don't need to see it anymore. Okay.
Okay.
Same thing for this one. The cosine of theta equals the adjacent over the hypotenuse.
Yep.
Get the adjacent by itself. We do the exact same thing. These cancel. I think I need to throw out this marker. Cosine of theta equals the adjacent. And,
Done.
And you guys have seen every single time hypotenuse of the sine of theta is opposite. Hypotenuse of the cosine of theta is opposite. If you
Yep.
remember that, you're golden.
A is equal to B over C. Just
Yeah.
solve for whatever
Yeah, and if
you
you're
got.
confused, just go back to your roots, your basic algebra.
What?
All right, so the vector resolution method. So these are the steps that you want to take to when you are resolving, when I'm asking you to resolve something. So first off, sketch the vectors, showing the angle to the reference
That's the
direction.
most important thing. That sketch is so important.
So important. If you don't sketch it, it is dang near impossible to really get your figuring out which one is adjacent.
You
which
gotta
one's
see it.
opposite.
You gotta see
Yeah,
it.
even I have to see it. Then use the cosine to find the adjacent side.
Just like we did over there.
and use the sign to find the opposite side.
Just like we did over there.
Okay.
Boom, boom, boom.
Work equals the component of the force in the direction of the displacement. So work equals force times displacement, and this is the direction of the displacement. Work equals the component of the displacement. Oh, that's the same thing.
Well, except it changes. So the component of the force in the direction of the displacement, and then the component of the displacement in the direction of the force. It all depends on your situation. They're both saying the same thing that equation in the middle says. Sweet.
Okay, I think I just got something in my eye. Okay, so you pull a black block with a scale that rates 8.5 newtons at that angle above the table. Do you want to go ahead and demonstrate?
Oh, I
this
think we
over
got
here?
it. That's this thing right here, isn't it?
Okay, so this is what we're asking you guys to think about. So we have a meter stick here that would measure at a certain distance, and we have our black block with the thing in it, and here's our scale. And what the question is saying is that at 35 degrees, I'm pulling this, and this force is reading something. I'm pulling up a certain amount of force.
Yeah. And we'll say that it's 8.5 newtons.
We'll say it's 8.5, and we'll say that that angle was exactly 35 degrees.
What's the first step we have to do? We need to do
Let's just draw it out. Let's,
make a sketch.
Yeah, let's
That's
make
right.
a
Oh, is
sketch
it going to erase?
it's getting better.
The longer you go without using that other stuff, the better it's going to be.
Yeah, this Moore's having some slight board erasing problems.
Technical issues with a whiteboard.
Don't worry, nothing she can't handle. Actually, you know what? I probably should have left those up there.
Nah, it's okay.
Yeah, you guys can refer to them.
They've got them in their notes.
Okay. Okay, so let's draw the sketch. So the black block, I'm just gonna go ahead and draw my block as a dot.
That's a free body diagram.
You pull the black dot and the scale reads, okay, so I pulled it like this, right?
Yep.
And we said it read 8.5 newtons. And we said it was exactly 35 degrees above the horizontal. I mean, you could see when I was pulling it there.
Yep. So the next slide says,
Yeah, what are we supposed to do? Oh, wrong way. What does the vertical component do? What does the horizontal component do? Okay, I'm gonna make this green. Okay, so we want to know this is the horizontal. And this is my vertical. And I'm just going to go ahead and use the equation that we just came up with.
well,
Oh, wait, let me label my sides
what is
here.
the vertical component is going to be trying to lift the block up off the table, right?
Oh, yeah.
So it's trying to lift it up, and that'll actually decrease the force of friction because it'll decrease the normal force. So the vertical component is trying to lift it up. And what is the horizontal component doing?
Pulling it forward.
That's one actually doing the work.
So this is the one that we want.
Yeah.
Okay, so what does the, so we actually, it's not asking us to calculate. Can
We could do
calculate?
that.
Let's
What
do
the
it.
heck?
So the question said, what does the vertical component do? The vertical component is just lifting up the block and reducing the friction.
So
right?
how much force is that? That's the opposite
well,
side.
Let's figure it out. So the opposite is, what do we say, the hypotenuse times the opposite, the sine of theta, right?
Yeah.
And so this is going to equal 8.5 times the sine of 35. Okay. 8.5 times the sine of 35. And I'm going to call it 4.88. 4.88.
I'm going to call it 4.9.
4.9 newtons.
4.9 newtons up.
Up. And then this part is the horizontal component. This part is pulling it forward. Okay, so the adjacent equals the hypotenuse times the cosine of theta, because the adjacent. So 8.5 times the cosine of 35. And I get 8.5 times the cosine of 35. And I get 7. 7 newtons.
So now you can see where that equation for work comes that has the cosine of the angle in it. Here, the component that's doing work is the horizontal, And so that's the one that you would use. You'd multiply that times the displacement. Boom, boom, boom.
Yes, 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 yes. So, and Boykin just said you use this horizontal component. This is the one doing work. This
Yep.
is perpendicular, so
No work being done.
no work. Okay. Okay. Oh, and here are your questions. You are going to do page 229, number 7, and number 8, as well as 242, number 12, 19 through 22.
These are review questions to get you ready for the half quiz that we're going to be taking tomorrow.
Good luck.